We finished up the first part of this presentation talking about the anatomy of the long bones. And from that discussion, there are a couple of things that you should have picked up. You should know what the shaft of the long bone is called. You should know, in fact, what the ends are called. So these questions are just some examples. You should understand what the material covering the outside of the bone is, as well as that that's on the inside. Know what the purpose of cartilage on the end of long bone is, as well as the cartilage that makes up the epiphyseal plate. And you should know what kind of cartilage it is that's involved in these structures. Now, let's talk about some surface markings on those. Surface markings are projections or openings. They're sites of muscle attachments, tendons, ligaments, nerves, blood vessels. And there are different categories of bone markings. We have projections and processes, which are things that come off of the surface of the bone. They are raised areas. They often start with the letter T, in fact. For example, the large processes on the femur are known as trochanters. Similar structures on the humerus are known as tubercles. Raised structures on other bones are sometimes referred to as tuberosities. Now, by no means are they all start with T, but if you see a T, you can pretty much know that it is a raised surface. By the same token, we have lots of depressions and cavities and holes, passageways for nerves and vessels, and these often start with the letter F. For example, the word fossa or foramen. Now, I'm not going to go through all of these by any means. This is located in your textbook, this table. And you should know, in general, this terminology. Particularly of benefit in laboratory activities, but you should understand that if I say a raised surface is, and I gave you a list, you would be able to pull, say, a trochanter or something similar out, as opposed to the terminology for depressions, like meatus or sinus or fossa. So be aware of those. Also know of the projections that actually form joints, a head, a facet, a condyle, and a ramus. These are terms that you should be aware of. Now, we've talked about the gross anatomy. Let's take a moment and talk about the microscopic anatomy of the bone. Compact bone is made up of small structures known as osteons, or Haversian canals. It is a structural unit of bone, and it contains a central canal and rings that surround it. Now, the central canal is an opening that carries blood vessels and nerves. There are perforating canals that go through bone, we mentioned those earlier, that go to the central canals of osteons. They carry blood and vessels to that central canal. So a cross-section of bone looks something like this. We have our periosteum. We have our blood vessels bound to the periosteum. We have perforating canals that go through, also known as Volkmann's canals. These canals lead to vessels that go up and down along the length of the long bone, and surrounding those is a ringed structure known as an osteon. Some vessels travel into the spongy bone, where they are able to collect red blood cells and white blood cells that are being manufactured by the spongy bone. Now, the osteon itself has several layers of structure and several terms you should be aware of. Lacunae and lamellae are two terms that start with L. If you were going through the materials on skin, there were a couple of words there that also start with L. There is lanula and lanugo, also L words. you should know the definitions of all of those words. Now, lacunae, these are cavities within bone that contain bone cells, specifically the cells osteocytes, which are sort of maintenance cells. The word lacunae means small lake, and the lacunae are arranged in the rings formed by the lamellae. And these are rings around the central canal, sites of the lacunae, and the lamellae form kind of like growth rings, except that instead of forming from the inner part out, they develop from the outside in until the vessel is completely enclosed. Now, that does not mean that you can cut someone open, cut into a bone and tell how old they are. Now, it would be tempting. That looks an awful lot like a tree-like structure. But the thing is that we rebuild bone constantly. And within just about 90 days, all of the bone at the end of my femur, or I'm sorry, at the end of my tibia, has been replaced by new bone. So this is not a way that you can tell someone's age. Anyway, here you see the central canal, and you see it as well here, and you see that we have rings of bone structure, and those rings of bony structure are the lamellae. Located in little pits in between those rings are the osteocytes located in the lacunae. And you see here small canals leading from the central canal called canaliculi. Single is canaliculus. This is where nutrients from the central canal pass to the osteons. So what we have is osteocytes located in lacunae between the lamellae, which receive nutrition from the central canal via the canaliculi. And canaliculi are tiny canals, again, that radiate from the central canal to the lacunae. They form a transport system connecting all the bone cells to a nutrient supply. Now, there are other cell types in bone, aside from the osteocytes. We actually have osteoblasts and osteoclasts, but they have different purposes, and we will talk about those in a subsequent discussion. Again, just as a final review, central canal, lamellae, which are the ring-like structures, lacunae, which hold osteocytes, and are fed nutrients via canaliculi. And at this point, we will stop with the discussion on general structure of bone. We will pick up in a later presentation on other aspects of bone. So thank you very much.